Today we're going to be looking at graphing exponential functions. Now there are two basic types of exponential functions. You have the normal base, like base 2, base 3, base 4, and then you have the exponential base, e to the x. Now they're both graphed the same way, they just have different bases. For example, here the base is 2, here we're in base e. Now to graph these, we're going to take a look at a couple of things. One, we need some points. So the first points that we're going to get, the first one we call it's called the parent point, okay, or the PP. Now to get the parent point, we're going to let the x value be 1. And if we let the x value be 1, we get y becomes 2. So the parent point becomes 1, 2. And then we're going to do what's called an extra point. Now to get the extra point, we're going to let x be 0. And if I let x be 0, y becomes 1. So if I were to sketch this, I have 2 points. One, I have the point 1 up 2. And then I have 0, 1. Now another important thing to remember is that if I let x get really small, like -10, this never becomes negative. Matter of fact, there's no value for x that can make it be negative. Remember, if I plug in 0, I get 1. So there's nothing will make this negative. So we have a horizontal asymptote at y equals 0. So there's an asymptote down here. And we use that to sketch it. If I start at the parent point, head towards the extra point, I'm heading down towards the asymptote. On the other side, we actually break away. It kind of goes up. This isn't rational, so it's not going to head back towards the asymptote. Only rational functions will head towards it. It just keeps going up and up and up. So remember, the parent point is at 1, 2. Now, if I want to do e to the x, the same thing. My parent point is going to be 1e. Our extra point, 0, 1 still. If I put 0 in there, again it's horizontal, y equals 0. And if I wanted to graph this, I graph the point 1, e. 1, 2, 3. You may recall e is about 2.71. So it's right here. Just a little steeper. And my extra point, 0, 1. Get my horizontal asymptote. And we graph towards the asymptote. Starting at my parent point, head towards the extra point and head towards the asymptote again. And then the other side just continues to go up. Now one thing we didn't talk about, domain and range. Of course the domain, all real, and the range, it starts at 0 to infinity. Same thing here. Now you can do the all real symbol, or you can do the negative to positive infinities here, of course, and the range 0 to infinity. So let's graph a couple of these. These are very easy to do. We like graphing exponentials as well as logarithmic functions. They're both kind of easy to do. So before we do that though, let's take a look at the general function. Here it is. Now if you notice, you got your b hat, b, h, a, and k. This is going to be our order for transformations. We'll talk about that in a little bit. The domain and the range, don't ever worry about these. We get them from the graph. Get from graph. Although most of you know we can get them from, they really come from h and k. Same thing. The horizontal asymptote, though, will be y equals k, always. The parent point, remember you're going to let x be 1, and if you let your x be 1, it's going to be the base. And the extra point is going to be 0, 1, always. And we explain why that is later in another worksheet. Same thing over here. We're going to get this all from the graph if it's e. Horizontal asymptote, still y equals k. The parent point, always 1 and the base. And the extra point, 0, 1. So let's graph one of these real quickly. Very easy to do. Kind of fun. I think they're fun, but you know, hey. Alright, so number 1, we want to graph the transformations. We have 2 of them, 1, 2. So I list out my b hat, b, h, a, and k. Just helps me out here. This right here, this x minus 1, that's not a b. B is what we're going to be multiplying by 1, so there is no b. That minus 1 is our h, and that is a horizontal shift. And it's going to go right 1. There is no a. Now be careful. Some people think, oh, look, the 2 is an A. That's not an A. An A will be something multiplied to the 2. This is not an A. That's my base. So be careful. So there is no A. There is a K, though, and it's called a vertical shift. And it's going down 4. All right. So let's go and take a look here. The horizontal asymptote, y equals k. So therefore it's y equals -4, because that's our k value. The x-intercept, y-intercept, we'll solve for those in just a few minutes. But let's go ahead and get our parent point. Remember, the parent point is 1 and the base, which is 2. The extra point, 0, 1. Always. And the domain and range, we'll get, so the x-intercept, y-intercept, domain and range, we can kind of get those ideas from the graph. So let's take a look at graphing this. Now, what I'm going to graph first are my points that I have. 1, up 2, and 0, 1. There is my parent point, and there's my extra point. Okay? And I'm going to transform, well first, and I'm going to graph my horizontal asymptote, -4. 1, 2, 3, 4. Missed. There's my horizontal asymptote. Now, I'm going to transform it, and that's why I like B hack. B, nothing. H, horizontal shift, it says to go right 1. Move my point right 1. No A, vertical shift, down 4. 1, 2, 3, 4. There is my new parent point. Same thing here. Take my extra point, right 1, down 4. 1, 2, 3, 4. And when I draw them, very simple, connect it to, there we go, and then it's going to go up, like so. All right. To get the x-intercept, well, let's do the domain and range. The domain, all real, and the range from -4 to infinity. To get the x-intercept, this is what we talked about yesterday, let y equals 0, we get 0 equals 2, x minus 1 minus 4. So basically 2 squared equals x 2, to the x minus 1. So what does x have to be? 1. That doesn't make any sense. Let's try it again. 3. There we go. Add 1. So we get the x-intercept 3, 0. To get the y-intercept, let x equals 0. So we get y equals 2 to the -1 minus 4. Not too hard to do. That's just 1/2 minus 4, or -3.5. So we get 0, -3.5. Very easy to do these. All right, let's take a look at the next one here. Okay, 3 to the -x. So if I list out my b hack, b, h, a, k. My horizontal asymptote is y equals 1. We'll start all this. My parent point 1. This time my base is 3. My extra point 0, 1. Always. We talk about why that is. Okay. If you ignore any transformations, right? It's y equals 3 to the x basically. If I let x be 0, we get y equals 1. That's your extra point. Get the b hack. We do have a b this time. That's a b right there. Okay. So it is in this case, it is a horizontal reflection. It's going to go over the x reflection. It's going to go over the y-axis. There is no h, so I'm not adding or subtracting. There is no a. There is a k. It's a vertical shift up 1. So what I'm going to do is I'm just going to graph this. Start off with my points. 1, 1, 2, 3. 0, 1. There's my parent point. And y equals 1. There we go. And I do all my transformations now. My transformation, it says to reflect it over the y-axis and then go up 1. There's my new parent point. Reflect it over the y, stays there, goes up 1, right there. And now when I graph it, notice what happens. Oh yeah, its direction has changed. And there we go. Now for this one, we don't really have to do much for the y-intercept. We already got that. It is 0, 2. So there's our y-intercept. To get the x-intercept, be careful, okay? To get the x-intercept, let y equal 0. So we get 0 equals 3 to the negative x plus 1. Now be very careful. I get negative 1 equals 3 to the negative x. Now there's two things I want you to notice. One, this never crosses the x-axis. Look at it. So it's obvious that there's going to be none right there. So it's obvious. But why not here? Because there's no x that's going to make this negative. This would have to be negative for it to happen. So we can't solve it that way. Negative can't equal a positive. See, a negative cannot equal a positive. Therefore, it's no solution. All right, so we're going to take a look at a few more on part 2, so make sure you go over there and take a look at them, okay?